So hello everyone. Today we'll be discussing problems A to D for CodeChef Starters 199. So am I audible, guys? Just confirm once in the chat. Hello, am I audible, guys? Okay. So let's start with the discussion. This is problem A, fence coloring. You have n fences and you want to color them. You have n total types of colors numbered from 1 to till n. Currently all the n fences are colored with the type 1 color. At the end you want the ith fence to have a color AI for every 1 to n. You can choose to do one of the following at each minute. Color all n fences at the same time with type X color, where you can choose X from 1 to n. Color a specific fence I with type X color, where you can choose X from 1 to n. Both of the above operations take only 1 minute to perform. What is the minimum number of minutes needed to color the entire fence as desired? So the constraints are n is given as 2e5, and so the expected time complexity would be, I think, O of n or O of n log n, because sum of n over all test cases does not exceed 2e5. So problem A. Basically, the problem says that we are given an array A, and we are also given n fences, 1, 2, 3, n fences, which initially have a color 1, and in every minute we can do two operations. We can do one of the two operations. First one is we can color all the n fences with some color X, or we can color some ith fence with the X color. So let's see the test cases now. Let's take the first test case, 2, 1, 2. So initially the color of fences will be 1, 1, and then we can choose this fence and color it as 2. So 1 minute would be required. So answer for this test case is 1. Then the next test case, 3, 3, 3. Initially all the fences will be color 1, and then we can color all the fences to the color 3 in 1 minute. So answer is 1. Then the next test case, 2, 1, 3, 2, 5, 2. 6, 2, 1, 3, 2, 5, 2. So basically all the fences initially have color 1. Now what we can do is, since we are seeing that there is a majority of 2 here, so we can color all the fences to the color 2, and then we can do 3 more operations to get the 1, 3, and 5 color. So our final array will be 2, 1, 3, 2, 5. This requires 1 minute. This requires 3 minutes. So overall 4 minutes will be the answer for this test case. So basically, what are the observations? The one important observation is that let's number these operations. Let's call this operation number 1 and let's call this operation number 2. So we will only do operation 1 once, because there is no point in doing the operation 1 twice or thrice or more than that, because we can because all of the previous operations wouldn't matter if we do the first operation again, since it colors all the array, all the fences. So we can just do that and skip all the ones before it. So we will only do operation 1 once. And another observation is we will do operation 1 in the beginning. So these are two operations that we make in this question, because there is no point in doing operation one after beginning, like after performing some other operations, because operation 1 would create the same array irrespective of what the array was just before performing the operation. So basically doing it after the beginning is not worth our while. So we'll always do operation 1 in the beginning, and we'll only do operation 1 once. So let's use this observation. Let's say that we perform operation 1 with color X in the beginning. So now what will happen is we would have taken 1 minute and our fences would look like this now. This is 1, this is 2, this is 3, this is n. And now for further operations, we will not perform the operation 1 again, since we observed that it will only be performed once. So now whichever elements are not X, we need to count those. So the answer for this would be 1 plus number of elements not X. Or we can write this like, we can also write it in this way: 1 plus n minus number of elements X. So the formula for this case would be n plus 1 minus number of elements equal to X. Okay. And then the other case is that we do not perform operation 1. If we don't perform operation 1, then the fences would look like this. This is 1, 2, 3 till n. And in this case, the time required would be number of elements not equal to 1. That is equal to total, that is n, minus number of elements equal to 1. So the final answer, considering all the cases, would be minimum of n plus 1 minus number of elements equal to X, n plus 1 minus number of elements equal to X for X 1 till n, and minimum of this and n minus number of elements equal to 1. Also we can set this as greater than 1, because for 1 we will never perform the operation 1 with the color 1, because the initial array already has all fences with color 1. So minimum of this would be the answer. Now we can calculate this in O of n log n by keeping this count in a map. This count in a map. So basically, also we can observe that this is just minimum of number of elements equal to X. Minimum of this for all X is just equal to minimum of n plus 1 minus frequency of maximum occurring element. Actually, maximum frequency of color would be maximum frequency of color. since we need to minimize this, we need to maximize this. Since this is in minus, so we maximized it, and taking minimum of this and what n minus number of elements, n minus number of elements not equal to number of elements equal to. So minimum of this would be the answer, and we can calculate this in O of n log n by using a map to store the frequencies of each element. So I'll show you guys the implementation. I take input n and then I count the frequency of each element using a map m, and f would store the maximum frequency. So minimum of n minus f plus 1 and n minus m of 1 would be the answer. So is this problem clear to everyone? If anybody has any doubts, they can ask in chat. Okay. So let's move on to the next question. So the next question is subtract or divide. So you are given a positive integer n in one operation. You can do either of the following two actions. So if n greater than 2, choose to change n to n minus 2. If n greater than 1 and n is even, choose to change n to n by 2. Find the number of different positive integers you can form if you are allowed to perform as many operations as you want, starting with n. Note that you are allowed to perform different types of actions in different operations. Okay. And there are 100 test cases when n has 10 to the power 9, so expected time complexity would be log n or log square n something. So problem B. Basically, you are given an integer n and you can perform two operations. Operation number 1 is change n to n minus 2 if n is greater than or equal to 3, and the other operation is you can change n to n by 2 if n is even. N greater than 1 does not matter because 1 is not even, so you can just say that n greater than 0. So these two are the operations, and we need to count the number of different numbers we can make from this n. So let's see the test cases. For 1 it will be 1 because we cannot perform any operations. For 2 it will be 2 because we get the number 2 and we can divide it by 2 and get the number 1. So 1 and 2 count would be 2. For 4 we can get 1, 2 and 4. For 6, let's see 6. So first of all, for 6 we can get 6, and then if we perform minus 2 we can get 4. If we perform again minus 2 we can get 2. Or from 6 we could have performed divide by 2 and we can get 3, and then from 3 we can do minus 2 and get 1. We could have also gotten 1 from here, so let's just do that, and these 5 numbers would be the answer. 8. From 8 we can get 8, 4, 2 and 1. From 8 I can get 6. Then from 6 I can get 3, and then I can get I think that's it. So this is again 6 of 6, and this is 5. For 9 9 we can get 9, 7, 5, 3 and 1. So we get 5 different numbers for 100. For 100 we'll get all the even numbers from 100, 98, 97, sorry 96 till 2. So this will be, I think, 50 numbers here, and then we can do if we do divide by 2 here, we will get 50, which is already here, and if we do divide by 2 here, we will get 49. So 49 is like the largest odd integer that we can get, because uh, applying the divide by 2 operation on any further integers would give us a bigger odd integer, or it would just give us a smaller odd integer, I mean, and applying the -2 operation would just keep on giving us even integers, because applying -2 on even would give us even integers. So 49 is like the highest odd number that we can get, and from this odd number we apply the -2 operations to get a further odd numbers. So 47, 45 and then till 1. So these are 25, I think 25, and total would be 75. 75. So basically one observation that we can make is observations. If we get some even number, then we can get all the even numbers smaller than that number. Basically, this is because let's say we got somewhere while doing the operations we get 10. So what we can do is we can just perform -2 operations and get all the even numbers smaller than 10. So we can do this and we'll get all the even numbers smaller than any even number that we get. So if we get some even numbers, then we can get all the even numbers smaller than that number. And another observation is same for odd numbers. Same for odd numbers. Basically, again, if I get some number like 9, then again applying the -2 operations will give me all the odd numbers smaller than 9. So using these two observations, what I can say is that the answer for this question is uh, highest odd number by 2 plus highest even number by 2. Actually, highest odd number plus 1 by 2, because for 9 it was we were getting 1, 2, 3, 4, 5 numbers. So 9 plus 1 upon 2, it's basically C. And for even, I think by 2 does the job. So highest odd number plus 1 and highest even number plus just highest even number by 2. So basically this will be our answer. Now this will give us the count of all the odd numbers that we get, and this will give us the count of all the even numbers that we get, and sum of both will be the answer. Now another observation is that the number always reduces after performing the operation. So basically, since the two operations that we have are divide by 2 and subtract by 2, so both of them are sure to decrease the number. So basically, from this observation, we can say that if n is even, then the highest even number is equal to n. And if n is odd, then highest odd number is equal to n. So these two observations we make. Now what is left is that when n is even, we need to find the highest odd number, and when n is odd, we need to find the highest even number. So let's solve for the second case first. Let's say that n is odd, and let's try to find the highest even number. So n is odd. So we have two operations, basically n minus 2 or n by 2. So doing minus 2 will always keep the parity same. Right. Basically, if the number is even, doing a minus 2 will keep it even. If the number is odd, doing a minus 2 will keep the number odd. So minus 2 always keeps the parity same. What about n by 2? N by 2 reduces a factor of 2 from n. So what this is, what can this do is, basically if a number is even, it can either make it even or odd, and if the number is odd, then we cannot perform this operation. So basically when n is odd, we can only perform this operation, and when we perform this operation, the parity will never change, so it will always be odd. So we will never get any even number. So basically this turns out to be 0 in this case. So answer when n is odd would be just n plus 1 upon 2. Or we can also say n by 2 plus 1. It's the same. Basically because this is floor, this is not, and this is floor. I mean, we don't need to do floor here because n plus 1 is even. So this. Okay, so let's see for the test case when n is even. So if n is even, then we get this series by doing the minus 2 operations. Now what we need to do is we need to get an odd number, right? So we'll get odd numbers by performing the by 2 operation, because we saw that the by 2 operation can transform an even number to either an even or an odd. Basically it can make an even number odd if it if we divide all the powers of 2. So we need to perform by 2 operations to get an odd number, and we need to now find the maximum odd number that we can get. So basically these all numbers are even, right? These are all even. Since n was even, so minus 2 operation doesn't change the parity, so all are even. So what we can do is perform the by 2 operation on them. So for n we get n by 2, and n minus 2 we get n by 2, n minus 2 by 2, which is n by 2 minus 1. Now we see that either this or this, one of them must be odd, because these two are two consecutive numbers. So one of the two consecutive numbers must be odd, and that will be the highest odd number. Because if we use any further numbers and apply the by 2 operation on them, then we will definitely get some number smaller than these two. We'll get some number smaller than these two if we perform the by 2 operation on the numbers further. So basically one of these two is odd, and that is the highest odd number. So the answer for this test case for when n is even would be n by 2 plus basically whichever, let's say that x is the odd number out of n by 2 and n by 2 minus 1. So x by 2 plus 1 will be the answer, where x is the odd number out of n by 2 and n by 2 minus 1. So let's just try this on one test case. So let's just try it on 100. So 100 n by 2 will get 50, plus then what we can do is apply the by 2 operation on 100 and 100 minus 2. So for this we get 50, for this we get 49. So 50 plus 49 by 2 plus 1, 50 plus this is 24 and 1. So this is 75. This is floor division by the way. So this is, we get the answer. Let's apply it on 9 as 9. We simply get n by 2 plus 1, which is 9 by 2 plus 1, which is 4 plus 1, 5. And for 8 again we need to apply this formula. So 8 by 2 plus, we can apply the by 2 operation. So 3 by 2 plus 1. So 4 plus 1 plus 1, 6. So that was the solution for this question. Also, since simply we need to just calculate a formula, we can do this in O of 1. I'll show you guys the code for this question. So LLN, CNN, and if n is odd, then I simply output n by 2 plus 1. Else if n was even, then I initialize my answer with the value n by 2, which is this part, and then I divide n by 2. And basically if I divide n by 2 and it comes out to be even, then that means this number was even. So I simply subtract 1 from the number to get this number, which is surely an odd number. And then I simply add answer plus n by x by 2 plus 1, so which is this term, and then see out answer. So are you guys clear with this solution? My solution, if n percentage 2, C out n plus 1 by 2, else C out n by 2 plus n plus 3 by 4. Yes, basically n plus 3 by 4 will come out to be this value. So I think it is clear for everybody. I'll just wait for a few seconds if someone has sent out. I didn't understand the part why n minus minus. Basically I divide n by 2. So I have gotten this value n by 2, and we needed to find out the the odd number out of n by 2, n by 2 minus 1. So basically if n is now even, basically I have divided n by 2, and if now n is even, I need to subtract 1 again, because this is even. I have gotten this to be even, so n by 2 minus 1 must be odd. So this value will be odd. So this value will be the value of x. So and if n by 2 was odd, then I wouldn't subtract 1 from it and just simply proceed. Is it clear now, Paritosh? For even, how n minus n by 4 works? N minus n by 4 works. If it works, we'll probably get it from this formula only. Let's just do this. Let's say n by 2 plus, we have x by 2, right? So x by 2 plus 1. So x can be either n by 2 or n by 2 minus 1. So let's just put those values in the formula. So we'll get x by 2 plus floor of n by 4 plus 1, or n by 2 plus floor of n by 2 minus 1 upon n. So this is n by 2 plus 1 2 actually n by 4 minus n minus 2 by 4, so 1 by 2. and this was also plus 1. This was n by 2 plus n by 4 plus 1. Hmm. So what we can do, we've got n by 2 minus 4 plus 1 n by 2 plus. Hmm. Also n is even. N is even. N is even, so this and this can be I don't know, this somehow would solve to n minus n by 4, only then the answer n minus n by 4 would work. So it must be solved to this. So I got it. I have implemented a while loop for nothing got to learn. Thank you. Does it actually work n minus n by 4? I don't know. For 100 we'll get 75, and for 102 we'll get 102 by 2, which is 51 plus 51 plus 51 by 2 plus 1. So 51 plus this is 25 plus 26, 77. 77. Oh, okay. So this is 102 minus 102 by 4. So 51 by 4. So 102 minus 25, which is 77. I don't. Yes, I think it would work. Uh, these two must be same as this. 400 it will be. Ah, okay, so let's move on to the next question, I think. So grid max. You are given an integer n, construct an n into n grid with n square integers. Let aij represent the element in the ith row and jth column. Define Vij be the set of all elements axy such that exactly one of x equal to I and y equal to j holds. In other words, Vij is set of all elements in the same row or column excluding I, j itself. The grid must satisfy the following conditions. Aij must be less than n square and Aij equal to max of Vij. So for each test case, we are given an n and we need to output the matrix corresponding to that n. So problems C. So basically, uh, we need to find a matrix 1 2 3 4 5. This is for 5 cross 5. So we need to find for a matrix where for each element I comma j, let's take this as I and j, this element is the max of set containing all these elements. So basically Aij should be the max of set of elements containing set of elements in that row and column, excluding AI, comma J. AI. Basically, Vij is the set of all elements in the same row or column excluding I, comma J itself. So basically, excluding this element, all the other elements are in the set Vij, and this element is the max of that set. So Aij equal to max of Vij. So let's just try to construct this. The test cases are very simple, so just let's try to construct for some bigger n. Let's try to construct for n equal to 4. So 1, 2, 3, 4. So for n equal to 4, let's just start by placing 0 here. So basically now all these elements and all these elements must not have 0 in them. Okay, and so let's just put here 1. So let's just put all ones. Now basically what will happen is for this element we have a 0 here, and we also have a 1 here. So this element cannot be 1 since the max of these elements would be definitely greater than or equal to 2, because we already have 0 and 1 in this Vi set. So basically we need to remove these two ones if we are putting 1 here. So what we can do is we can try this. We can put 1 here, and we can now put 2 and 3 here, because we cannot put more ones here, or we cannot put the same element, because then the max would not remain the same. So basically this will satisfy for the 0, and it won't create any problems for any other element. So let's try to fill this row now. So we've got 1 as the max here, and we need the max to be 1. So we need at least 1 0, and now we can not put any more zeros, because then this 0 will not have the max 0. So what we can do is we cannot put 3 also. So basically we can put 3 here, and we can put 4 here. So that won't create any problems for any other number, since 3 is greater than 2 and 4 is greater than 3. Then let's try to fill this row. So we have got 2, and we have got 1 and 0 here. So we cannot put 1 here, we cannot put 0 here, and we cannot put 2 here. So what we can do is we can put 3 here. Wait. Okay, I think we can put 3 here. And oh, I'm sorry. Okay, just a second. Sorry. We can do 1 0 1 2 3, and then what we can do is since we have got 1 here, we need a 0 in this. We cannot we have 0, and we need to put 0 2 and 3 in this row. We cannot put any ones, so we can just do 0, and since now for this element we cannot put any elements, we cannot put any zeros here, and but we need a 0, and since if we have a 0 here, so we cannot put a 0 here also. So we need to either put a 0 here, because we need to put 0, 1 and 3 in this row and 0, 1 and 2 in this row. So we need to put 0 somewhere here, and let's just look for some patterns that can work. We can maybe just do this 0, 1, 2 and then 0, 1 and then 0. So this way we will not have any same elements in the row in the same column, and we can put, since we already have 0, 1, 2 in this row, so we can put 3 here, and now 3 cannot come here or here, so 3 will come here in this row, and now 3 cannot come here, here and here, so 3 will come here in this row. So we can put 2 here and we can put 1 here, and I think this will work because this is 0 and no other element is 0 in this row. For this 1 we have a 0 and we have 3 and 2. For this 2 we have 0, 1 and 3. For this 3 we have 0, 1 and 2. And the rows will never be a problem because they are basically, all the left elements are smaller and all the right elements are smaller and all the left elements are larger. So rows will never be a problem. And the columns, we've checked that for 0 we don't have 0 here. For 1 we don't have 1 here. For basically, since all the elements are identical, so it won't be a problem. Since the max will already be calculated by the row, since all the right elements are larger and all the left elements are smaller for each row. Sorry. I'm sorry. Since like all the elements in each row are unique and all the elements in each column are unique, so the each particular element in each row and column would be the max for that column, for that row and column, since we have already got all the other elements for all elements in that row or column to be unique. So this process will always work, and so we need to ensure all elements in a row and column are unique. So how can we ensure this? We can simply do this. We can put 0, 1, 2, 3 till n, and now we cannot put 0 again in this column. So we will start putting 0, 1, 2, 3 till n minus 1, and then we'll start putting 0, 1, 2, 3 till n minus 2. And the rest of the elements we can put here n. We can put n minus 1. Sorry, n minus 1 and n. Now for this 0 we can go to 1 till n minus 3. So we'll get n minus 2, n minus 1, n. So, and at the bottom we will have 1. Sorry. And 0 here. Okay. So this will make sure that each row has all the numbers from 1 to n, 0 to n, and all the elements in the columns have all numbers from 0 to n. So the max would always be the whatever element we are looking at, because it is unique in both the row and column, and we have all the numbers from 0 to n. So I think if anyone has any doubts in this solution, they can ask. For j equal to 0, mat ij equal to I, else mat ij equal to mat ij minus 1 plus 1 percentage. And basically in questions like this, there can be multiple solutions. You just need to observe and you'll get one of the solutions. That's why I was having a hard time actually explaining why I got this solution, because I just happened to arrive it like while finding some matrix n equal to 4, 5, etc. So these types of question, you just, there can be multiple solutions. Everyone can get different solutions. So if anyone has doubts, they can ask. Actually, we are doing till D. Yes, we will be doing perfect ranges. Okay, so let's move on to the next question. Perfect ranges. So in this question, we are given a pair of arrays A and B, both of length n, are called perfect if it is possible to form an array C of length n satisfying the following conditions. So Ci is equal to Ai or Ci is equal to Bi for each I 1 to n, and Ci must be less than Ci plus 1 for each I 1 to n. So you are given two arrays A and B of length n. It is guaranteed that each element from 1 to 2n either occurs once in A or occurs once in B. So find how many pairs L and R exist such that the pairs of array A, L and L comma R and B, L comma R are perfect. So here A, L comma R is okay. So and for this question is given as 2 to the 2e5. So we are probably expected to solve in n or n log n. So problem, we are given two arrays A and B of size n, and we need to count the number of subarrays L comma R. Count L comma R such that A L comma R and B L comma R is a good pair. What is the definition of a good pair? A pair of arrays are called good if we can make another array C from them, where Ci is Ai or Ci is Bi and Ci is less than Ci plus 1. So good pair for each Ci is, we can, Ci is equal to Ai or Bi and Ci is strictly increasing. So basically let me just state one quick observation. A L is to R can be good only if L R minus 1 is good. Basically, how am I saying this? Because if LR minus 1 is not good, then there is no way LR can be good, because we can already not form the array C in the elements from L to R minus 1, and we can obviously not form the array C in the elements from L to R. So LS to R can only be good if and only if LR minus 1 is good. So basically, what we can say from this is, if LS to R is good, then LS to X is good, where X is from L plus 1 till R. So basically, we can use this observation to try and change the question a little. We can find the maximum R for each L. We can find the maximum R for each L, and then R minus L plus 1 will be the number of subarrays, number of good subarrays starting from L. So we have kind of changed our question to this. We need to find length of longest subarray, good subarray, starting at each L. So basically, we are fixing L and trying to find the longest good substring starting with this L, starting at this L. We are trying to maximize on the R. So how can we do that? Let's try some test case. Let's try this test case. Maybe I think we can try this test case too. Or let's just try it first, because in this all the substrings are good. So 264315. So let's try and solve. So basically, we can either take 2 or we can either take 3 from the first. So let's start by taking 2. So we take 2. Then we can we have only one option of taking 6. So we can take 6, and then we don't have any further options. So if we take 2, then the maximum starting here will be 1. Maximum length will be 2. If we had taken 3, then also the next element that we could have taken was 6, and then we cannot take any more further. So if we had taken 3, then again the maximum length possible would have been 2. So basically, the answer for this L will be 2. Now let's try to find for this L. If we take 6, then the answer would be 1, because we cannot take any other element. If we take 1, then the answer would be 2, because after 1 we can take 5. So 2, and the maximum of 1 and 2 will be 2. So again we can take 2 elements for this L. Now for this L, whichever we take, we will get 1 as the maximum length. So answer for this L will be 1. So total answer will be 5. So we can see sub problems being created here. We saw that when we picked up on 2, we saw that the next element we could have taken was 6, and now the problem for L is now equal to L plus 1, whatever the maximum length possible from L plus 1 in that. So when we chose 2, we went to the next element and we got that we can only take 6 here. So now this is like a separate, different problem, different sub problem that we have now. So basically, when we are calculating from 3, then again we have the same sub problem. So we can kind of see that this problem can be solved using DP. And since there are, we can just define this state DP of I comma type, which where type basically means where type can take three different values, 0, 1 and 2. 0 basically means that we are starting at this L and we haven't taken any numbers from the past. Basically we are starting our good subarray here. For 1 it means that we have taken A of I minus 1, and for 2 it means that we have taken B of I minus 1. So basically this was array A and this was array B. And DP of I comma type stores the maximum length possible starting at I with the last element being type. So basically let's try to identify the state in this problem. So let's again take that test case 264,315. So we need to find the number of we need to find the length of the longest substring starting at 0th index, right? So that would be DP of 0, 0. Since we haven't taken any elements previously and are starting fresh from the 0th index, so type will be 0. So now we can either choose the first element as 2 or we can choose the first element as 3. So what happens if we choose the first element as 2? We get that we can just transition this to the state DP of I 1 plus DP of 1 comma 1. So this one means that the last element that I had taken was 2, and now I need to find the longest length starting at this index. Or the other transition would be 1 plus DP of 1 comma 2. So this means that the last element that I have taken is 3. So now we need to calculate 1 comma 1 and 1 comma 2. So what is DP of 1 comma 1? Since the last element that I had taken, 1 tells me that the last element that I had taken was 2. So I can only perform the transition where the current element is greater than 2. So I can only perform this transition DP of 1 plus 2 comma 1. I cannot perform DP of 1 plus DP of 2 comma 2. This I will not be performing because this state told me that the last element in my sequence was 2, and now I have to take some element that is greater than 2. So I can only take 6. So I can only perform this transition. And then I need to calculate DP of 2 comma 1. So DP of 2 comma 1 tells me that the last element that I had taken was 6. And since there are no elements that I can currently take, so the answer of DP of 2 comma 1 will be 0. So this value will be 0 and this value will come out to be 1 and this value will come out to be 1. So for 2, the answer would be 2. Now for 3, again, I will calculate DP of 1 comma 2, which is this. And DP of 1 comma 2 will again have only one transition, which is 1 plus DP of 2 comma 1, since we can only take 6. And the value of DP 2 comma 1 already calculated as 0. Okay, sorry. DP of 2 comma 1 as 0. Yep. So DP of 1 comma 2 will come out to be 1. And we will put value 1 here and we'll get the value of this as 2. Now let's try to find for this L. For this L, the value would be DP of 1 comma 0 because we are starting fresh from this index. So what will be the transitions? We can either take 6 or we can either take 1. So we'll have both the transitions. 2 comma 1. We'll be taking max of these two because In reality, we'll be only taking one. So max of both the transitions, here we have 2. So dp of 2 comma 1, this will be 0, we have calculated. So this is 1. And dp of 2 comma 2, dp of 2 comma 2 will have one transition. We'll have two transitions actually, because we can take both the elements. So this will be 1 plus dp of 3 comma 1 and 1 plus dp of 3 comma 2. And since there aren't any more elements after 3, so we can just put 0 to these and we'll get the value of 2 comma 2 as 1. Then we can put value 1 here and we'll get this as 2. So the value for this is 2 and the value for this will be 1. Because so this is 2 and this is 1 and the maximum of those will be 2. So that way we'll get the answers, and for this it will always be 1, because we can choose any and we won't have any further options. So total answer would be 5. So let me just state the solution once again with proper states and transitions. So we have dp of I comma type. So for dp of I comma 0, the transitions would be max of 1 plus dp of I plus 1 comma 1 and 1 plus dp of I plus 1 comma 2. And for dp of I comma 1, max of 1 plus dp of I plus 1 comma 1, 1 plus dp of I plus 2 comma 2, I plus 1 actually here. And this transition now will only be possible when a of I minus 1 was smaller than a of I, and this transition will be possible only when a of I minus 1 was smaller than bi, because this is signifying that I had chosen bi as the ith element, and this is signifying I have chosen ai. Similarly, for this, we will again have these two transitions for cases where bi minus 1 is less than ai and bi minus 1 is less than bi. And for base case, when I equal to n, return 0. So the total number of states in this dp is n into 3, and total and average transition per state is 2. So the overall time complexity will be 6n, which is well within the limit. So now I'll show you guys the code. So dp of I type, and here I've written a little comment reminding me of what the type means. So 1 is basically array A and 2 is basically for array B and 0 is for starting fresh. So this is the base case, and this is for memoization. If type 0, then answer is basically max of both those transitions. If type 1, we'll add a if statement, and if type 2, again we'll add that if statement and return dp. And basically I have taken input, I have initialized the dp with -1 value for memoization, taken input, and then for all L, I have added the total, I have added the maximum length, and then that would be the answer. So are you guys clear with this solution? How you solve such deep questions? You need to identify the sub problems in such question to solve it. Basically, when you identify the sub problem, you can then guess what will be the state required to solve this, and from that state you will now know the transitions. How many problems will it take to gain this mastery? That is dependent on the person, but if you keep solving, you'll get better. So if someone has any doubts in this question, they can ask. I created 2D DP and returned max sum among the 2D DP. Max sum, actually 2 1D DP. Okay, yes, I think you can do that as well. Yep, that is fine. That is fine. You can basically create two DPs. Range बता दो number of problems की. Um, that depends on what kind of background you have. Basically, you can solve very less number of problems and get better very quickly if you have like done a lot of maths previously. So yeah, don't worry about the range. That don't think that you'll reach a certain level if you solve X number of problems. Just keep solving problems and you will definitely reach that level now or after some time. So I think you guys don't have any further doubts regarding the question. So I'll be ending the live stream. Thank you. I have average background like 10K rank in advance. Now tell. So um I cannot tell the specific number of problems that you need to solve still, but like you can, whatever topic you are feeling like that you are struggling in it, you can solve lots of problem on that. So you must have some strong topics of yours and some weak topics of yours, so you can just put time in those weak topics and you'll get better. Okay, so I'll be ending the live stream now. Thank you.